Our next topic is operations with rational expressions, and we're going to do another monster problem that is going to include adding, subtracting, multiplying, dividing, simplifying, and nested fractions. So just like the one we did with straight numbers, we're now going to add in some variables, but the processes are going to be the exact same. So as I go through this example, be sure that you are pausing the video to make sure you understand each step, and thinking back to the last example where we had just the numbers and drawing those connections, because all of the steps are exactly the same, the rules are exactly the same. So we are going to start, just like we did in the other problem, by looking at this numerator, and we need to make this numerator into one single fraction. In order to do that, I have subtraction. So just like when we subtract fractions with numbers, I need to have a common denominator. Okay? Here, instead of breaking these denominators into factors, we're thinking of this x minus 5 as a factor and 4 as a factor. So this one over here is missing a 4, right? So we need to multiply the numerator and denominator of this first fraction by 4. And that 4 is going to be applied to both of these pieces. Okay. Then over here, I am missing the x minus 5. So on this fraction, I need to multiply by x minus 5 on both of those pieces. Okay. From there, I'm going to multiply out. Yes. From there, I'm going to multiply. So here I have 4x minus 16. So this becomes 4x minus 16. Then I have minus x minus 5 times x minus 5, which we'll distribute in a second, over this common denominator, which is now going to be 4 and x minus 5. Now, that was just the numerator. The denominator is just a single fraction, so I don't need to do anything in terms of combining denominators. Oh, school's out. So I am going to just take this one, and remember that this fraction sign here actually means divided by. So instead of thinking about this as a much larger fraction, I'm going to do this and write divided by this fraction. Okay, so this fraction bar is turning into this division sign. X minus 5 over 4. I'm right here, x minus 5 over 4. And I'm just going to kind of ignore that until I simplify this big mess over here. Okay, so now that I've moved on to here, I need to simplify the numerator. 4x minus 16 minus, I need to distribute this. So you can use your area model if you need to, or we're using distribution. So I have 4x minus 16. I'm going to keep a large set of parentheses here, and you'll see why in a second. We have x squared, okay, minus 5x and minus 5x. So that would be minus 10x, and then plus 25. All over 4 times x minus 5. Okay, and to save myself some space and some time, instead of just writing this over again, I know that I'm dividing by a fraction. So ultimately, I know that when I divide by a fraction, that's the same as multiplying by the reciprocal, right? Flipping it upside down, just like we did in example 1. So I'm going to change this to a multiplication sign, and I have 4 over x minus 5 now. So I flipped that whole second piece. Now we're going to keep simplifying this big crazy one over here. The reason I included parentheses is because of this minus sign. So when you're doing subtraction, you have to be really careful to remember that this minus sign, we're subtracting all of these terms. So this minus is going to be distributed. So I have 4x minus 16 minus x squared plus 10x minus 25 all over, I'm keeping this as 4 times x minus 5. And then I have times, I can't do anything over here yet, so I'm just going to leave that until we get to that step. Okay. Now, in the numerator here, I can combine like terms. Okay. So I can combine my like terms. I always want to write my term with the largest exponent first. So I want my negative x squared to go in the front. It has nothing to combine with it. Okay. Then I have 4x plus 10x is positive 14x. Minus 16 and minus 25 gives me minus 41 over 4 times x minus 5 times 4 over x minus 5. Okay, I'm going to move it over here because we're running out of room. But the next thing that I would want to do is take this here and factor it if I can. Because now I'm at the point that I have one simplified fraction times another simplified fraction, and I'm hoping that something will cancel out or eliminate to make my larger fraction more simple. Okay, I want to check and see if this factors. I'm thinking about two numbers that multiply to be negative 41 and add to be 14. Okay, but I do have this negative in the front here. So in order to eliminate that negative sign or to take it out of my factoring, I'm going to pull the negative out into the front and then like it's a greatest common factor. Okay, so when you have a leading coefficient that's negative, it's going to make it easier to factor if you pull that negative out. So then I would have positive x squared minus 14x plus 41. Okay, and then I still over 4 times x minus 5. And then I still have my times 4 x minus 5. Okay. I'm hoping that what will happen is that this will factor so that I can cancel it out with a factor down here. But unfortunately, nothing multiplies to be 41 and adds to be negative 14. So this does not factor. So I'm going to leave it how it is. At this point now, I'm multiplying fractions. I need to see if there's anything that I can cross out that's the same on the top and the bottom. So here I do have a 4 here and a 4 here. It does not matter that they're in different fractions. Because it's multiplication, this is really all one big fraction. Okay? What matters is that one is on the top and one is on the bottom. So those divide out to be 1 or cancel out. I'm going to redistribute this negative here. Negative x squared plus 14x minus 41 over, these were not able to cancel out, even though they're the same, right? Because they're both on the bottom, so we can't cancel them out. So what I'm going to do instead is factor them out, or FOIL them out, distribute them out. So I have x squared minus 10x plus 25. Okay, this is my final answer because nothing could factor and nothing could simplify. Okay, this right here, when we distribute it back out, this is called expanded form. So if you're asked to leave something in expanded form, this is what it means. It means that there shouldn't be any parentheses left. You should have distributed everything out. If it asks for it in factored form, we could have stopped up here and left this as our factored form with these two being in your denominator.
Michael Raimundo, please come to the office.
So let's go back and analyze the different skills that were all in this massive problem. Okay, we conquered our nested fraction, right? So this was our nested. This was our nested that became a division sign over here, right? So our nested became a division sign. Okay. We had our subtracting, which is the same as adding, and we got our common denominator, right? We had to get our common denominators here. Common denominators, okay? Then we made sure that we distributed this negative, right? So that's something that we often make a mistake on. Okay. Remember that when we divide, we flip the fraction and we multiply instead. We multiply by the reciprocal. Okay, so this is our division process. Down here we simplified. Okay. I took out that negative to see if I could factor this. In this one I couldn't factor it, so I was not able to cancel anything other than these 4s. This is the simplification process. So if you see instructions that say simplify, this is the process they're asking for. And then I got my final answer, and remember this is expanded form. We know it's expanded because it no longer has any parentheses. We did all of the distribution. Before we move on to graphing, there are a couple of little things that I wanted to remind you about or show you in terms of simplifying. Okay? So here, a lot of times students are tempted to do this. Okay? That is not allowed, not legal. Here's why. Okay? If you look at the number version, if we have 2 plus 3, okay, over versus 1 plus 3, right? If I have 2 plus 3 over 1 plus 3, when I simplify, the value should stay intact. It's like we're simplifying fractions, but it represents the same amount. So 2 plus 3 is 5, 1 plus 3 is 4. Okay? So when I simplify this, I should still get a ratio of 5 to 4. If I cancel these out, I instead get a ratio of 2 to 1. See how those are not the same? That is why we cannot do this. What we have to do instead is think about anything that's bonded with addition or subtraction as a unit. So if it doesn't have parentheses, draw the parentheses. It helps to remind us that we're keeping it together as a unit. If the entire unit is the same, if the pieces being added are the same as the pieces being added, then I can cancel this whole block with this whole block. That divides to be 1. The pieces being separated, I cannot individually simplify those. So be careful of that. Other things to notice, x plus 4 and 4 plus x. Are those the same? Hopefully you said yes. Because remember, if it's addition, I can rewrite terms in whichever order I want, as long as I keep the sign the same. So if this is x plus 4, that is the same as 4 plus x. So these units would cancel, and they would equal 1. Right? Because canceling is really dividing to equal 1. That's what we're really doing. Here, is this the same? Okay, be careful with this. This, if I rewrote it, I have x minus 4 over negative x plus 4. Okay, those do not look the same. However, look what we can do. This, I'm going to keep this as x minus 4. If I take a negative out, like I did in the last problem, if I treat a negative like a greatest common factor, if I pull out a negative, that would give me x minus 4. Okay. So now, these two blocks are the same. I can cancel those, but I still have this negative. So if you have a situation like this, you can still cancel it. You just have to be really careful to make it equal to negative 1. So if the signs are flipped, that means that they do cancel out still. They still make 1, but they make negative 1 because their signs are opposites of each other. So be on the lookout for that. Sometimes you can simplify farther than you think with this information.